We're going to talk about two types of variation, direct variation and inverse variation. Let's start with this statement. If y is directly proportional to x, then y equals k times x, where this k here is just a constant. It's either called the variation constant or the constant of proportionality. Now, what's going on here in this equation is if x gets bigger, y also gets bigger. And if that's the relationship between two variables, x and y, that's an example of direct variation. Let's look at some real-life examples of direct variation. First example, the cost of an item and the sales tax paid for the item. As the cost of the item goes up, the amount of sales tax you have to pay for it also goes up. Another example would be the distance between cities on a map and the actual distance between those cities. As one increases, so does the other. And one more example, the amount of exercise that you do and the amount of calories that you burn. Okay, so that's direct variation. Let's look at another kind of variation, inverse variation. If y is inversely proportional to x, then y equals k divided by x, where again, k is the variation constant or constant of proportionality. And if we look at what's happening in this formula, k again is just a constant, so it's not changing. So as x gets bigger, y gets smaller. Also, as x gets smaller, y gets bigger. These two variables, x and y, are demonstrating inverse variation. Let's look at some real-life examples of inverse variation. My first example is the number of workers digging and the time it takes to finish the hole. As the number of workers goes up, the amount of time that it takes to finish this job is going to go down. That is an example of inverse variation. Another similar example is the speed with which you run versus the time that it takes to finish the race. The faster you run, the faster you get finished with the race. So in other words, the higher the speed, the lower the time. And my last example of inverse variation is the age of a car and the value of the car. As the car gets older, the value of the car goes down. So in other words, as age increases, value decreases. Now that we have our basic formulas for direct and inverse variation, let's do a quick couple of examples. R varies directly with S. Let's just start there. If R varies directly with S, we can immediately write down a formula. R equals k times s, where k is just some constant, and we can see that as s increases, r increases. Now the second part of this problem is giving us some information. They're saying that s equals 2 and k equals 4, and they're asking us to find r. So all we have to do is take that s and plug it in there, and take that k and plug it in there, and we get r equals 4 times 2, or r equals 8, and that problem is finished. The next problem says that m varies inversely with O. Find m if O equals 3 and k equals 6. So the first thing we can do is look at this statement. If m varies inversely with O, because we have inverse variation, our formula is going to look like this. Then we're told that O equals 3 and k equals 6. So we can plug O equals 3 in right here and k equals 6 in right here. We get m equals 6 over 3, or m equals 2, and that problem is finished. You'll notice in each of these examples, we're first writing down an equation that relates the variables that are given. This is always called an equation of variation. Let's take a look at a couple of other problems. This one says y varies inversely as x. That right there tells us that we're going to have an equation of variation that looks like this. Because the problem says inversely, we have y equals k divided by x. Then we're given some information. Y equals 5 and x equals 10. If we plug y equals 5 and x equals 10 into this equation of variation, we now notice that we have an equation with just k as our unknown. That's the variation constant, and that's what we want to find in the second part of the problem. So how do we solve this equation for k? Well, k is being divided by 10, so to get k by itself, we're going to have to multiply both sides of the equation by 10. That leaves us with k by itself on the right side and a 50 on the left side, and that problem is now finished as well. Let's look at one more example that adds a couple of complications. First, the statement says that y varies directly as the square of x. Let's take care of that one first. Y and x vary directly, so our equation of variation is going to look something like this. But you'll notice that y varies directly as the square of x, so that means that we need an x squared in this formula. So our equation of variation is y equals k times x squared. Next, we're given some information. When x equals 3, y equals 2. So we can plug that information into our formula. That gives us 2 equals k times 3 squared. And all we're able to do with this equation is solve for k. If we square 3, we get 2 equals k times 9. If we want to get k by itself, we need to divide both sides of the equation by 9. That gives us a variation constant, k equals 2/9. Now our original equation of variation look like y equals k times x squared, but now we have k equals 2/9. So I'm going to plug that k equals 2/9 into this formula, and we get y equals 2/9 x squared. That is our new equation of variation for this problem. Finally, we're told that x equals 4 and we're asked to find y. So we can take that x equals 4, plug it into this final equation of variation, and we get y equals 2/9 times 4 squared. We can simplify this. 4 squared equals 16. If we multiply 16 times 2/9, we can think of that 16 as 16 over 1. In other words, that 16 just multiplies the numerator of the 2/9, and we get 32/9 as our final answer. Okay, I hope this gets you started on the homework. I'll see you in the next one.